Welcome students, we are expected to solve this question, integral dx over third root of tan x. Now you might be tempted to take tan x to be equal to u cubed, but this wouldn't work. Now for this to work, what we would do is we would have to make the following substitution. That is, we would have to take tan squared x to be equal to u cubed. So this is the substitution that would be working for questions of this fashion. So it's a standard prototype, so have that in mind. So if I were to take tan squared is equal to u cubed, then from here I can rewrite, okay, so this would mean I have tan x is equal to u raised to the power of 3 over 2. So this is one deduction. Now you will know why am I writing for tan x within a few minutes, because if I were to differentiate this tan squared x, I would get 2 times tan x, right? And then differentiation of tan x is secant squared x times dx. So that is the reason I need to have a representation or an equivalent variable for tan x which has a u being featured in it. So that is the reason I have just rewritten tan squared x is equal to u cubed for tan x. So this is actually differentiating both sides. So on the right hand side I would get 3 times u squared times du. Now I have made the substitution for tan squared x, but I would have to extract dx, and after extracting dx, then the original integral can be rewritten in terms of u. So there are a few things we will have to do. So from here what I want to do is I will have to extract dx. So dx is equal to 3 times u squared times du divided by 2 times tan x times secant squared x. Okay, that's fine. I've got a representation for tan x, so I can place that here. But what is secant squared x? Now we know that secant squared x negative tan squared x is equal to 1. So from here secant squared x is equal to 1 positive tan squared x. But my tan squared x is equal to u cubed. So this is going to be equal to 1 positive u cubed. So that's fine. So this is going to be equal to 3 times u squared du divided by 2 times my tan x is u raised to the power of 3 over 2 times my secant squared x is 1 positive u cubed. This is my dx. So all of these things is to make sure that proper understanding is rendered to the reader. So this is going to be rewritten as, in place of dx I got 3 times u squared du divided by 2 times u raised to the power of 3 over 2 times 1 positive u cubed. So this is for dx. Now I've got a third root of tan x, right? Now just place the third root there. Third root of, in place of tan x I'm going to substitute u raised to the power of 3 over 2. That's it. So this can be rewritten as, now 3 is a constant, take it out, 2 is a constant, take it out, integral, we got a u squared there, place that, times du divided by, now third root of u raised to the power of 3 over 2. What is the understanding for that? So let me just show you that. U raised to the power of 3 over 2 is here, and it is actually third root there. So this can be rewritten as u raised to the power of 3 over 2. Because of the third root is going to be 1 over 3. So 3 can be cancelled, giving you u raised to the power of 1 over 2. So that is the simplification. So I'm going to use that. So this is 2 times u raised to the power of 3 over 2 times this u raised to the power of 1 over 2 times 1 positive u raised to the power of 3. Now 3 over 2 added with 1 over 2, the law of indices, right? A raised to the power of m times a raised to the power of n is a raised to the power of m positive n. So by applying this rule, this is nothing but a raised to the power of 3 over 2 times a raised to the power of 1 over 2. This is going to be a raised to the power of 3 over 2 added with 1 over 2, which was going to be a raised to the power of 4 over 2, which is going to be a squared. Over here is a squared. Over here it's going to be 2 u squared. Actually I have taken the 2 out, so I don't have to place the 2 here again. So this is equal to 3 over 2 times integral u squared. These two are clubbed together, giving me u squared times 1 positive u cubed, right? So now we can safely cancel these two u squared, and then we are left with 3 over 2 integral du divided by 1 positive u cubed. Now there is a formula. We know that a cubed positive b cubed is equal to a positive b times a squared positive b squared. So let me check this out. So this is the formula, right? Now if I were to multiply a with, just for the sake of clarity, right? So a multiplied with a squared would give me a cubed. A multiplied with negative ab would give me negative a squared b. A multiplied with b squared is going to be a times b squared. Positive b times a squared, negative a times b squared, and positive b cubed. So this formula is actually the right formula. Why do I say that? Now clearly you can see that negative a squared b can be cancelled with positive. So ab squared can be cancelled negative ab squared. So we are left with a cubed positive b cubed. So we can't make any mistakes in applying the formula. So it's always better to have a check on that. So in place of this, I can have this. But we do not have a cubed positive b cubed. So what do we have? We got 1 positive u cubed. This is what we've got. So all the way from here, we have reduced the system to 1 positive u cubed. So in place of a, I've got 1. In place of b, I've got u times 1 negative u positive u squared. Okay. So this is the substitution that I would be utilizing here. So this is equal to 3 over 2 times integral du over 1 positive u times 1 negative u positive u squared. Now I would like to use partial fraction. So what I would do is I would just consider the term. So what is the term? 1 divided by 1 positive u times 1 negative u positive u squared. Now I'm going to rewrite this as a over 1 positive u positive b, in fact bx positive c, right? So it's going to be bu positive c divided by 1 negative u positive u squared. Because of the degree 2, this is the form we have to use. If I were to cross multiply, I get 1 is equal to a times of 1 negative u positive u squared positive b times u positive c times 1 positive u. So this is what we have got. Now what I would do is I would just make the following substitution. So let u be equal to negative 1. So if I were to take u is equal to negative 1, this will be off. If this is off, I would get a times of 1 negative of negative 1 positive negative 1 raised to the power of 2, which is equal to a of 1 negative negative positive. This is going to be positive. This is going to be 3 times a. On the left I got a 1. Therefore a is equal to 1 over 3. So we got that. Next I will take u to be equal to 0. Let u to be equal to 0. So this is off. So I'll get a c. So 1 is equal to a times of 1 0 0 positive of c. So this is going to be a positive c, but a is 1 over 3. So 1 over 3 positive c. So from here 1 negative 1 over 3 is equal to c. So 3 negative 1 over 3 is equal to c. Therefore 2 over 3, c will be 2 over 3, right? So we can write that down. C is equal to 2 over 3. So I've got I have taken the value for u. I've taken the value, I've taken it as negative 1, and I've taken it as u being equal to 0. So now I need to extract one more u. In other words, I need to take a value for c. I need to extract the value for b. So I've obtained the value for a, I have obtained the value for c. Now what we can do is we can take some independent value for u. So let u be equal to some positive 1. It doesn't matter. So 1 is equal to a times of 1 positive 1. So that's going to be 1 with a negative sign there. Positive 1, positive b, positive c, and 1 positive 1. Right? So this is going to be a. This is going to be 2 times b, positive 2 times c is equal to 1. I know the value for a is 1 over 3. I know the value for c, my value for c is 2 over 3. So 2 over 3 times 2. So this is going to be 1 over 3 positive 2 times b, positive 4 over 3. Now I can add these two together. Right, so that would give me 1 added with 4, positive 2b, right, that's 2b. So this is going to be 5 over 3 positive 2 times b is equal to 1. I move this 5 over 3 to the other side, so it's going to be 1 negative 5 over 3 is equal to 2 times b. So 3 negative 5 over 3 is equal to 2b. So this is going to be negative 2 over 3 is equal to 2b. There's a negative sign, so 2 gets cancelled, so therefore the value of b is negative 1 over 3. So I've got the value for a, value for c, and the value for b. So what I need to do is I will have to take this as, say, some 2. So therefore 2 can be rewritten as, I'm going to write it down here, so therefore 2 is rewritten as 3 over 2 times integral, I'm going to write it like this, a over 1 positive u, positive bu, positive c divided by 1 negative u, positive u squared times du. Now I know the value for a, so this is going to be 3 over 2 integral 1 over 3, so it's going to be 1 over 3 times du divided by 1 positive u, and this is going to be integral b is negative 1 over 3 times u, and my c is 2 over 3 divided by 1 negative u positive u squared times du. So this is what we have got. So now we need to do some simplifications. We use the space. So we have got 3 over 2 followed by 1 over 3 integral du over 1 positive u followed by a positive sign and integral negative 1 over 3 times u positive 2 over 3 times du divided by 1 negative u positive u squared. This is what we have got. Now what I wish to do is I would like to simplify this. So for that, let me just consider this part alone. So I'm going to be simplifying this part first because this is already known, right? So consider this part, negative 1 over 3 times u positive 2 over 3 times du divided by 1 negative u positive u squared. This is what we've got. Now what I want to do is I would like to take negative 1 over 3 out. Now if I were to take negative 1 over 3 out, this would give me u negative 2 times du divided by, let me rewrite this as u squared negative u positive 1, right? Negative 1 over 3 times u would give me negative 1 over 3 times u. Negative 1 over 3 multiplied with negative 2 would give me positive 2 over 3. That's fair enough. Now if I were to make the substitution, let u squared negative u positive 1 be equal to some t, you would get 2 times u negative 1 times du is equal to dt. I need to get a 2 here and I need to have a negative 1 there. So what I want to do is I would like to multiply u with 2, so I will get a 2u. So that would mean I would have to compensate it with 1 over 2 here, because 1 over 2 multiplied with 2u would give me u, followed by, there should be a negative sign, so let me just have the negative sign here, right? So that into du divided by u squared negative u positive 1. Now please observe here, 1 over 2 times 2u, this is fine, we have got the first term. 1 over 2 negative 1 would give me negative 1 over 2. So I'm not getting a negative 2 there, but I'm getting only negative 1 over 2. So to compensate that, I need to have a negative 2. So how am I going to get a negative 2? I need to have negative 3 over, this is going to be, let me just work it out here, negative 1 over 2 added with negative 3 over 2, negative 4 over 2, which is going to be negative 2. Okay, that's fine. So this is going to be negative 3 over 2 integral du over u squared negative u positive 1. Okay, fair enough. So this is the simplified, or I should say this is the term that would give us the solution, and that has been obtained from the part that we have considered. So this looks all fine. So now what we need to do is, we need to take this entire thing and place it over here. So this is equal to 3 over 2 1 over 3 integral du over 1 positive u, followed by, I have actually taken negative 1 over 3 out. So this is going to be negative 1 over 3 parenthesis 1 over 2 times integral 2u negative 1 times du divided by u squared negative u positive 1. This is one part, followed by negative 3 over 2 integral du over u squared negative u positive 1. This is the next part. So let me just integrate this part. So I will say consider integral 2u negative 1 times du divided by u squared negative u positive 1. So let u squared negative u positive 1 be equal to some t. I differentiate, I get 2 times u negative 1 times du is equal to dt. So this is going to be integral dt over t, which is equal to ln t, which is equal to ln of u squared negative u positive 1 with the arbitrary constancy. So this is for this. So let me just place it. So this is equal to 3 over 2 1 over 3. This is going to be ln of 1 positive u negative 1 over 3. This is 1 over 2 times this quantity ln of u squared negative u positive 1. I'm not going to place the arbitrary constant c now. So this is the term, followed by negative 3 over 2 times, now u squared negative u positive 1. Now we can write u squared negative u positive 1 as a perfect square. So I'm going to rewrite this as u negative 1 over 2 raised to the power of 2. Let me just see that. When I expand it, I get u squared, and negative 2 times u divided by 2, that's going to be u, right? Positive 1 over 4, that's fine. To positive 1 over 4, I need to add a 3 over 4. So that would mean the perfect square is fine. So this is going to be negative 3 over 2 integral du divided by u negative 1 over 2 raised to the power of 2 positive 3 over 4. I'm going to write 3 over 4 as root of 3 divided by 2 raised to the power of 2 and parenthesis. This is nothing but x squared positive a squared. I can use the formula for tan, right? the formula that we know. Integral dx divided by x squared positive a squared is 1 over a tan inverse of x over a positive c. I can use this formula for this. So if I were to use this formula for this is going to be, let me rewrite that down. This is equal to 3 over 2, 1 over 3 times ln of 1 positive u negative 1 over 3 parenthesis 1 over 2 times ln of u squared negative u positive 1. So this is one term, that's fine. Negative 3 over 2, 1 over a. So 1 over a is root of 3 divided by 2 tan inverse of x over a. X over a is going to be u negative 1 over 2 divided by a is root 3 over 2. So I will have to do some clearing here. So let me rewrite this. This is equal to 3 over 2, 1 over 3 ln of 1 positive u negative 1 over 3 1 over 2 times ln of u squared negative u positive 1. If I flip this, the 2 and the 2 will get cancelled, right? So this is going to be negative 3 over root of 3 tan inverse of x over a. X over a is u negative 1 over 2. That's going to be 2u, u negative 1 over 2 is going to be 2u negative 1 divided by 2. And if I were to flip it, tan inverse of x over a, if I were to flip this, this is going to be 2 divided by root of 3, right? And a parenthesis. I'm not going to place a positive c as such now. So 2 and 2 can be cancelled. So this can be rewritten like this. This is equal to, if you were to bring 3 inside, this is going to be 1 over 2 times ln of 1 positive u, and I'm bringing 3 inside. In fact, there is one more parenthesis because this 3 over 2 is basically covers for the entire term. So there will be one more parenthesis, right? So we need to just add that one more parenthesis. Okay, so that's not an issue for us. So what we can do is I have just taken 3 over 2 inside. So now if I were to take 3 over 2 inside, clearly this 3 and this 3 will get cancelled. So that would give me negative 1 over 2, and I have a 1 over 2 here, so it's going to be 1 over 2 squared because 1 over 2 will be flowing inside. So that's going to be ln of u squared negative u positive 1. So 1 over 2 is actually coming inside. Right, 1 over 2 is actually coming inside because the 3 is already gone. So if 1 over 2 comes inside, there is a root 3 here. So I can neutralize the root 3 with the root 3 over there. So that would mean I will left with root 3 divided by 2, right, times tan inverse of 2u negative 1. Of course, the 2 that we see here, they both get cancelled, giving us root of 3, right? So that is looking good. Let me check one more time. Let me check if everything is fine. So the 3 over 2 comes inside. I get a 1 over 2. That's fine. The 3 gets cancelled. I get 1 over 2 squared. That's fine. So negative, negative. That's a positive sign there. And the root 3 gets absorbed there, and the 2 is actually flowing inside. So that's the reason we get this. So we have a positive c there, but we will have to revert the u back, right? So let us do that. So we got this u cubed is equal to tan squared x. So therefore u, this is tan squared x, therefore u is going to be tan raised to the power of 2 over 3 times x. So we will have to revert this substitution. So if we were to do that, that's equal to 1 over 2 times ln of 1 positive tan raised to the power of 2 over 3 times x negative 1 over 2 squared ln of my u is tan squared x. So if I were to square this, that is going to give me tan raised to the power of 4 over 3 times x negative tan raised to the power of 2 over 3x positive 1 positive root of 3 over 2 times tan inverse of 2 times of my u is tan raised to the power of 2 over 3 times x negative 1 divided by root 3, right, positive arbitrary constancy. So this is what we have got, and it's a good place for us to stop. So let me draw the beautiful red line. So that is the end of the solution. Thank you, students. Enjoy your day.